Intrinsic dissolution rate, intrinsic dissolution study, or IDR. This is the topic for the video. And intrinsic dissolution is performed on the pure substances, pure drug substances, to understand the nature of the drug substance. It is critical factor in the drug formulation development. Intrinsic dissolution, as the name indicates, it is the inherent property of the drug substance. Intrinsic dissolution rate, or IDR, refers to the rate at which the drug dissolves from a constant surface area under a constant hydrodynamic conditions in a given dissolution medium. It is an inherent property of the drug substance, and this property, or the intrinsic dissolution rate, is independent of the formulation factors. So, for intrinsic dissolution rate, the pure drug substance is used. Many of the time, the intrinsic dissolution testing is performed as a part of pre-formulation studies. IDR helps in predicting the drug solubility, bioavailability, and pH dependent solubility and precipitation, especially for the poorly soluble drugs. Many of the scientists use IDR to select the specific polymer or salt form during the drug development. So why IDR is important? Because it has some important aspects which provides you the information regarding the drug solubility, BCS class, formulation development information, and also for the regulatory requirements. IDR determines whether the drug is dissolution limited or permeability limited in its absorption. It helps to classify the drug into BCS classes based on the solubility, and this IDR information provides valuable information and guidance for excipient selection and formulation strategies for enhanced dissolution. Also, some of the regulatory agencies require IDR studies for the poorly soluble drugs. Which factors affect the intrinsic dissolution rate? Mainly the crystal form, polymorphism, then pH of the dissolution medium, particle size and surface area, temperature and hydrodynamics are the important factors affecting the intrinsic drug dissolution rate. Different polymers or crystal forms have different solubility, and that's why different intrinsic dissolution rates. pH can affect the IDR, and it can vary significantly based on the pH, for example gastric pH versus intestinal pH. Particle size and surface area affect the IDR. Smaller particles have higher intrinsic dissolution rate because of the increased surface area. Temperature and hydrodynamics play the critical role in IDR. Higher temperature and increased stirring rate can enhance or accelerate dissolution. So now coming to the procedure for measuring the IDR. USP chapter is there which provides you the information on IDR measurement, mainly rotating disk method, and Hansen method is used for IDR measurement. Rotating disk method, Wood's apparatus is there to test the IDR. A tablet with a fixed surface area rotates in a dissolution medium, and the dissolution rate is measured in the Wood's apparatus. Then another method is Hansen IDR method. It uses stationary disk instead of rotating one for more controlled testing. So one thing here is to understand that the constant surface area is the main important factor for the IDR. Then some diffusion control models are there which are based on to the principles of Noyes-Whitney equation. Now coming to the IDR in BCS classification. As we know, there are 4 BCS classes, BCS class 1, 2, 3 and 4, and these have impact onto the dissolution. For BCS class 1, rapid dissolution happens and it is not a concern for the effect. BCS class 2, these are low soluble and high permeable molecules. So dissolution rate is the limiting factor for absorption. BCS class 3 have high solubility, so permeability is the limiting factor. BCS class 4, these are low soluble, low permeable, so poor dissolution and permeability are the challenges for formulation development. For BCS class 2, drugs IDR enhancement techniques like salt formation, micronization, solid dispersion can be used. So enhancing the IDR for poorly soluble drugs. You can prepare the salt so that the solubility can be increased and IDR can be enhanced. Then reducing the particle size, micronization, making the nanoparticles. Amorphous solid dispersion is another important factor or procedure for increasing the dissolution rate. You can make the use of surfactants and co-solvents as well. Overall aim of this IDR study is to understand the intrinsic nature or inherent dissolution properties of the drug substance, and then various measures can be taken to improve the solubility and dissolution of the poorly soluble drugs. IDR is an important factor in drug formulation development, especially for the poorly soluble molecules like BCS class 2 drugs. It influences the drug absorption, bioavailability, and it is required for regulatory approvals. So optimizing intrinsic dissolution through formulation technique is a key for improving the performance of poorly soluble drugs. This is the apparatus as given in the USP chapter 1087 for intrinsic dissolution study. I will be making another video for the procedure for intrinsic dissolution. Consider this video as a introduction and basics. Intrinsic dissolution rate is also measured sometimes when there is a reformulation activity is done. Sometimes the formulation behavior changes over time or in different conditions or storage conditions or stability studies. That time also the intrinsic nature of the API or drug substance is required to be studied to understand the effect of formulation process and API aging onto the dissolution. I hope this video is able to give you the information for intrinsic dissolution rate, that is IDR, and some basic idea about the IDR. In the next video, we will learn regarding the IDR in more details. Thank you for watching the video.